In this module, you will learn about the periodic trends in the chemical reactivity of elements. You are already aware of the periodic trends in the fundamental physical properties such as atomic or ionic radii, ionization enthalpy and electron gain enthalpy of elements. Let's now see how the periodicity in these properties is related to the periodicity in the chemical reactivity of elements. While moving from left to right in a period, the atomic and ionic radii decreases. As a result, the ionization enthalpies increase and the electron gain enthalpies become more negative across a period. In other words, alkali metals of group 1 have the lowest ionization enthalpies, and halogens of group 17 have the most negative electron gain enthalpies. Low ionization enthalpy, as in the case of alkali metals, means that the elements are willing to give away their most loosely bound electrons. In other words, alkali metals are good reducing agents and are highly reactive in nature. The most negative electron gain enthalpy being attributed to halogens indicates that halogens behave as good oxidizing agents and exhibit high chemical reactivity. This is in contrast to the noble gases that have completely filled outer electronic shells and thus exhibit a positive electron gain enthalpy and the least reactivity. Chemical reactivity is the highest for both alkali metals and halogens. The maximum chemical reactivity at the extreme left of a period among the alkali metals is due to the lowest ionization enthalpy, which enables it to lose an electron that leads to the formation of a cation. On the other hand, the maximum chemical reactivity at the extreme right among halogens is due to the highest electron gain enthalpy, which facilitates an atom to gain an electron, leading to the formation of an anion. This property of forming cations and anions can be related to the oxidizing and reducing behavior of the elements. The chemical reactivity of an element is best shown by its reactions with oxygen and halogens. The alkali metals and halogens show a higher tendency to combine with oxygen as compared to the elements in the center. The oxides formed by the elements on the extreme left of a period are basic, while those formed by the elements on the extreme right are acidic in nature. For example, sodium, a group 1 alkali metal, forms sodium oxide with oxygen, which on reaction with water forms a base called sodium hydroxide, NaOH. In contrast, chlorine, a group 17 halogen, on reaction with oxygen, forms a highly acidic oxide called chlorine heptaoxide, which on reaction with water forms perchloric acid. Oxides formed by elements in the center are either amphoteric, like aluminium oxide, or neutral, like carbon monoxide. Amphoteric oxides can behave both as acids and as bases depending upon whether they react with a strong base or a strong acid. Neutral oxides, on the other hand, are neither acidic nor basic. The trend of oxides of the third period is observed as from strongly basic to weakly basic to amphoteric to weakly acidic to strongly acidic. Let's now consider the chemical reactivity down a group in the periodic table. The atomic and ionic radii typically increase down a group. As a result, for representative elements, the ionization energies gradually decrease and electron gain enthalpies become less negative down a group. Also, the metallic character increases down the group while the non-metallic character decreases down the group. Therefore, the chemical reactivity increases down a group for alkali and alkaline earth metals, while it decreases for halogens down the group. In the transition metals in the third series of the periodic table, the change in atomic radii is much smaller as compared to those for representative elements across the period. Similarly, the inner transition series 4F and 5F elements show even smaller variation in atomic radii. The ionization enthalpies of the transition and the inner transition elements are intermediate between those of S and P blocks. As a consequence, they are less electropositive than group 1 and 2 metals. You have now reached the end of this module. In this module, you learnt that the trends in the chemical reactivity of elements can be explained based on the trends in fundamental properties like atomic and ionic radii, ionization enthalpy, and electron gain enthalpy. The alkali metals and halogens show a higher tendency to combine with oxygen as compared to the elements in the center. The maximum chemical reactivity among the alkali metals is exhibited by the loss of an electron, and in halogens is shown by the gain of an electron. The alkali metals and halogens of a period can easily combine with oxygen and form acidic and basic oxides. Oxides formed by elements in the center are amphoteric or neutral. Down a group, the chemical reactivity generally increases for the alkali and the alkaline earth metals and decreases for the transition elements.